When installing low-voltage thermostat wire to control a rooftop air conditioning unit, the National Electrical Code and best practices dictate specific cabling requirements. The primary cable types permitted are Class 2 cable, Class 3 cable, or thermostat-specific cable. Class 2 cable is typically rated for 25 volts or less and 100 volt-amps or less. Class 3 cable is rated for 150 volts or less and 150 volt-amps or less. Thermostat-specific cable is shielded or unshielded cable designed specifically for use with low-voltage thermostats, and it is typically 18 to 24 American wire gauge with stranded copper conductors. Several additional considerations should be taken into account. Firstly, it's recommended to use stranded copper conductors to prevent breakage due to vibration. Secondly, the cable should be rated for the appropriate temperature range for the outdoor environment in which it is installed. Thirdly, the cable should be adequately protected from moisture and physical damage. It is also vital to follow the manufacturer's instructions for the specific thermostat being used. Examples of suitable cables include 18 American wire gauge Class 2 shielded thermostat cable, 22 American wire gauge Class 3 unshielded thermostat cable, and 24 American wire gauge thermostat specific cable with color-coded conductors. When selecting a cable, it is crucial to verify that the voltage and volt-ampere ratings of the cable are suitable for the thermostat and air conditioning unit being used. Also ensure compliance with all relevant local and national electrical codes, referencing the 2014 NEC for guidance. The NEC provides detailed requirements for Class 2 and Class 3 circuits in Chapter 7. Article 725 covers remote control, signaling, and power-limited circuits, which includes Class 2 and Class 3 circuits. Specifically, Articles 725.121 and 725.124 address the overcurrent protection and wiring methods for these circuits. Always consult with a qualified electrician or electrical inspector to ensure that the installation complies with all applicable requirements. Shielded cable is often preferred in environments with high levels of electromagnetic interference, as the shielding helps to protect the thermostat signal from being disrupted. When using unshielded cable, be sure to route it away from potential sources of interference, such as power lines or other electrical equipment. The American wire gauge of the cable is also an important consideration. Smaller American wire gauge numbers indicate thicker wires, which have lower resistance and can carry more current. For longer runs of thermostat wire, it may be necessary to use a thicker gauge wire to prevent voltage drop. Voltage drop occurs when the voltage at the thermostat is lower than the voltage at the power source, which can cause the thermostat to malfunction. The amount of voltage drop that is acceptable depends on the specific thermostat being used. Consult the thermostat manufacturer's instructions for more information. When connecting the thermostat wire to the thermostat and air conditioning unit, be sure to use appropriate connectors and terminals. Properly tighten all connections to prevent loose connections, which can cause arcing and overheating. If you are not comfortable working with electricity, it is best to hire a qualified electrician to install the thermostat wire. Working with electricity can be dangerous, and it is important to take all necessary safety precautions. Before working on any electrical equipment, always turn off the power at the circuit breaker. Use a voltage tester to verify that the power is off before touching any wires. Wear appropriate personal protective equipment, such as safety glasses and gloves. By following these guidelines, you can ensure that the low-voltage thermostat wire is installed safely and correctly, and that the rooftop air conditioning unit will function properly. Remember to always prioritize safety and to consult with qualified professionals when needed. The selection of the appropriate cable also depends on the environment where the installation will take place. If the cable is exposed to direct sunlight, it should be sunlight resistant. If the cable is buried underground, it should be direct burial rated. If the cable is installed in a wet location, it should be suitable for wet locations. The cable should also be protected from physical damage. This can be accomplished by routing the cable through conduit or by using a cable with a rugged outer jacket. The type of conduit used should be appropriate for the environment. For example, PVC conduit is suitable for underground applications, while EMT conduit is suitable for above-ground applications. The size of the conduit should be large enough to accommodate the cable without overcrowding. Overcrowding can make it difficult to pull the cable through the conduit and can also damage the cable. When pulling the cable through the conduit, use a pulling lubricant to reduce friction. Do not exceed the maximum pulling tension of the cable. The pulling tension is the amount of force that can be applied to the cable without damaging it. The pulling tension is typically specified by the cable manufacturer. After the cable has been pulled through the conduit, secure it to the conduit using cable ties or clamps. The cable ties or clamps should be spaced according to the manufacturer's instructions. The cable should also be supported at regular intervals to prevent it from sagging. Sagging cable can be a safety hazard and can also damage the cable. When terminating the cable at the thermostat and air conditioning unit, be sure to use appropriate connectors and terminals. The connectors and terminals should be compatible with the type of cable being used. The connections should be tight and secure to prevent loose connections. Loose connections can cause arcing and overheating, which can be a fire hazard. After the connections have been made, inspect them carefully to ensure that they are properly installed. If any problems are found, correct them immediately. Before energizing the circuit, test it to ensure that it is working properly. Use a multimeter to check the voltage and current. If the voltage or current is not within the specified range, troubleshoot the circuit to find the problem. Do not energize the circuit until the problem has been corrected. Working with electricity can be dangerous, so it is important to take all necessary safety precautions. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. A qualified electrician has the training and experience to install electrical wiring safely and correctly. The electrician will also be able to ensure that the installation complies with all applicable codes and regulations. The importance of using the correct type of cabling for low-voltage thermostat wire to control a rooftop air conditioning unit cannot be overstated. Using the wrong type of cable can lead to a variety of problems, including electrical shock, fire, and equipment damage. It is essential to follow the guidelines provided in the National Electrical Code and to consult with qualified professionals when needed. The NEC is a comprehensive set of standards that covers all aspects of electrical wiring. It is updated every 3 years to reflect the latest advances in technology and safety practices. The NEC is adopted by most states and local jurisdictions in the United States. It is important to be familiar with the NEC requirements for low-voltage thermostat wiring. In addition to the NEC, there may be local codes and regulations that apply to electrical wiring. It is important to check with the local authorities to determine what these requirements are. When selecting a cable for low-voltage thermostat wiring, it is important to consider the following factors: the voltage and current rating of the cable, the temperature rating of the cable, the environment in which the cable will be installed, the type of insulation on the cable, and the size of the conductors in the cable. The voltage and current rating of the cable must be high enough to handle the voltage and current that will be flowing through the cable. The temperature rating of the cable must be high enough to withstand the temperatures in the environment in which the cable will be installed. The environment in which the cable will be installed will determine the type of insulation that is required on the cable. For example, if the cable will be installed in a wet location, it must have a waterproof insulation. The size of the conductors in the cable will determine the amount of current that the cable can carry. The larger the conductors, the more current the cable can carry. It is important to select a cable with conductors that are large enough to handle the current that will be flowing through the cable. When installing low-voltage thermostat wiring, it is important to follow all safety precautions. Always turn off the power at the circuit breaker before working on any electrical wiring. Use a voltage tester to verify that the power is off before touching any wires. Wear appropriate personal protective equipment, such as safety glasses and gloves. Never work on electrical wiring when you are wet or standing in water. Be careful not to damage the insulation on the wires. If the insulation is damaged, the wire can short circuit and cause an electrical shock. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do work. A qualified electrician has the training and experience to install electrical wiring safely and correctly. The electrician will also be able to ensure that the installation complies with all applicable codes and regulations. Remember that properly installed and maintained low-voltage thermostat wiring is essential for the safe and efficient operation of your rooftop air conditioning unit. By following the guidelines outlined in this narration, you can help to ensure that your wiring is installed correctly and that it will provide years of reliable service. When running the thermostat wire, avoid sharp bends or kinks, as these can damage the wire and reduce its lifespan. Use cable staples or ties to secure the wire to the building structure at regular intervals, ensuring that the wire is not stretched or compressed. Maintain a neat and organized appearance and avoid running the wire across doorways or walkways where it could be damaged. Label the thermostat wire at both ends to identify its purpose, making it easier to troubleshoot any problems that may arise in the future. Keep a record of the wiring diagram and the location of the thermostat wire for future reference. When connecting the thermostat wire to the thermostat and the air conditioning unit, double-check the wiring connections to ensure that they are correct. Incorrect wiring can cause the thermostat or the air conditioning unit to malfunction. After the wiring is complete, test the thermostat and the air conditioning unit to make sure that they are working properly. If you encounter any problems, consult the manufacturer's instructions or contact a qualified technician for assistance. The long-term performance and reliability of your low-voltage thermostat wiring depend on proper installation and maintenance. Regularly inspect the wiring for any signs of damage, such as frayed insulation or loose connections. Repair or replace any damaged wiring immediately to prevent further problems. Keep the wiring clean and free of dust and debris, which can accumulate over time and affect its performance. Consider using a surge protector to protect the thermostat and the air conditioning unit from voltage spikes, which can damage the electronic components. By taking these precautions, you can extend the life of your low-voltage thermostat wiring and ensure the continued reliable operation of your rooftop air conditioning unit.